Good afternoon. You're on Likeable Science. I'm your host, Ethan Allen, and we're all about thinking how much fun science is, helping people understand that science is an engaging, accessible, very fascinating part of their lives. To help me explore these issues today is Sunny Walsh. Sunny is a civil engineer, and we're going to talk about all kinds of aspects of engineering today to help us understand how engineering ties to science, how engineering can make our lives better, both sort of in a broad sense and here in Hawaii in particular. So Sunny got her bachelor's degree from Worcester Polytech Institute in Massachusetts back in 1997. She's worked as a project engineer on a number of different sites, including the famous Boston Big Dig and then a variety of different places out here in Hawaii. In last year, in 2013, she was vice president of the Building Industry Association of Hawaii. So thank you for joining me, Sunny.
Thank you, Ethan.
So we really want to look at sort of the bigger picture of how engineering can really help improve lives here in Hawaii, but let's sort of start with maybe a couple basic definitions. So what really is civil engineering that you talk about?
Well, civil engineering, most people think about bridges is one of the first things you start with, and that's true. Civil engineers deal with the design, construction, and maintenance of different structures like bridges, roads, buildings, deal with wastewater treatment. And that's a pretty broad perspective of what civil engineering is.
So it's all sort of the built infrastructure of society, as it were.
Absolutely.
Okay. So within then civil engineering, there must be sort of specialties, people who work on one thing or another, people who work on just on airports or just on high-rises or different kinds of things.
Exactly. So I've done a lot of construction project management, working here, worked for a contractor, and generally we manage the project. We manage all the different subcontractors performing some of the work ourselves, if it's the concrete work or pile driving work, but then all of the other trades fall under us, and we are essentially the manager, and we work between the trades and with the owner and the architects and other engineers.
Right, so you help make sure everything, that the plumbing works with electrical, works with the concrete, the structural things themselves.
Mm-hmm.
Yes, okay, so that's an absolutely critical thing, because of course if those don't all work together, your whole building is...
Yeah, and then it's a complete failure.
Right. Okay, well, great. And so civil engineering is just really one form, though. I mean, there's a lot of other sort of parts and pieces of engineering, a lot of other routes you could have taken, right?
Well, you'll think about mechanical engineering. When I was in school, my friends who were mechanical engineering majors wanted to design car engines. Mechanical engineering also deals with manufacturing processes, acoustical, and anything that's more like moving parts, a lot of it. You also have chemical engineering, where you're dealing with how to take like natural resources and developing them into a usable resource. You think of like changing fuel, raw petroleum, or being able to make it into a usable fuel, or even taking plants and developing them into medicine.
Right.
And like electrical engineering essentially is dealing with electricity, electronics, and goes into computer engineering.
Right, so the boundaries are not exactly clear in some cases.
Exactly.
It ties into the whole nanoscience, nanotechnology field. In some cases, material sciences gets right into engineering too. Mm-hmm. Yes, okay. So this is then but you deal with a part that's very close to our lives, right? That's the structures we live in and we work in, we drive over, we rely on to take care of our basic human needs.
Yep, and we're the ones that you would complain to when the roads are bumpy, or if we're in your way when you're trying to get to work on time.
Oh, good. I'll get your phone number.
Yeah, please give it out to everybody.
So what got you interested in engineering as a field? It's fairly unusual for women to be in engineering, particularly, I think, civil engineering, if I'm not mistaken.
You are correct there. Early on, I always had an interest in math and science as a kid, and then so that developed into, well, how can I apply that? Really, I was I had some good role models when I was in high school, and I thought, well, what could I do? Engineering seemed reasonable. I decided to go to engineering school. I didn't know exactly what I wanted to do, and when I I thought, well, maybe I'll design roller coasters. It seemed to make sense at the time.
Sounds like fun.
Yeah. And then I got into school and started taking some different classes, and I thought, I actually really thought I was going to do wastewater treatment plant design, which doesn't sound exciting, but seemed exciting to me.
Compared to roller coasters,
yeah.
Right? A little different.
And then when I went to, then I actually started working for a geotechnical design firm. So we did foundation design, pile driving, pile design, and then I started to see construction project management as a field and saw how that, working with those people, with the project managers, I thought that's interesting. You know, you're in charge of everything, and a diverse range of projects. I've worked on high rises, I've worked on the Big Dig, as you mentioned, micro tunneling projects. There's almost no limit to what you can work on.
Okay, all right. Well, with all of them, it's the same kind of thing. It's looking at how do you fit all these different parts and necessary components of the project all together, get everything scheduled in the right way so the right people, the right expertise, the right materials all show up, hopefully on time and on budget, right?
That is always the goal. Yeah, and in Hawaii in particular, it can be particularly challenging. We're so far away from all of our resources, and even including our manpower. Sometimes the workers are not here, and we have to bring them in. Some of them are very specialized skills that there aren't necessarily lots of people who can do them. So trying to find those resources and coordinate them and get everyone to work together is a big part of what I do. Okay, well, good. And so what is it that you really like about engineering? What is it that gives you satisfaction? I do enjoy when working in the field and the large range of projects I get to work on and things that I get to do. Working in construction in particular, you start off with, there's an early phase when you're bidding projects, and that's can be a frustrating phase because there's a lot of tedious work, and there's a lot of deadlines, and you don't know what's going to come of it. You don't know if you're going to get a project or not, but then you get a project, and there's that excitement and elation of success. But when you actually start working, there's always challenges, even if you're building the same type of project. I said, oh, this is similar to the last one. It's still different. There's always new challenges. You're always going to run into something that you weren't expecting. So that's always fun, and it's interesting. And then at the end, there's such a tangible item that you can look at. You look at a structure. I worked on that with a huge team, and we were able to coordinate and create this building. Right, when there was nothing there before, now there is this well-organized, functioning, useful infrastructure, as it were. Yeah, no, that must be a great satisfaction. It is. Right. Excellent. So why is it, given sort of that you enjoy this and all that, why do you think it is there are relatively few women engineers? Well, I thought about that, and and you talked about how did I get interested in it, and I said I've always been interested in math and science. A huge part of that was when I was a kid, especially from a young age, I was inspired and encouraged to be interested in science and math from a young age. My mom would take me to museums, science museums, natural history museums. So we went to a lot of museums, and introduced me to all of that. And I thought that was, I used to love that. I used to love to go to the science museum. That was a big treat for me. And my grandfather, who I think he actually wasn't even able to finish high school. He grew up during the Great Depression and wasn't able to finish all the way through high school. But as a kid, he was always interested, always read, always wanted to learn more about science. And we'd watch Nova together and Jacques Cousteau, and not necessarily engineering fields, but science. And he would teach me those things, and he'd show me, he'd explore this with me, and he was brilliant, and I thought he was brilliant. So, and always having those types of influences as a kid and people in my life to encourage that and help me explore it and share it definitely helped. That's intriguing. I've past segments of my life worked in the area of informal science education, museum, science center world, and people talk about those pivotal experiences in science centers that make kids realize suddenly, like, yeah, this is very neat stuff. This is like really exciting. This is sort of what I want to do. This is what
brings me a lot of happiness. And it's interesting to hear from somebody who's not in that again, how that helps shape your understanding. So you would think that perhaps a lot of girls just don't get the mentoring, the role models, don't have those experiences somehow.
I think so. I never had a thought in my head, or I never had anyone tell me, you might face challenges. This is maybe a job in science or engineering isn't for you. There aren't a lot of women there. I was always told you can do whatever you want. And whenever I had an interest in something, I was always encouraged to explore it. I remember I had a chemistry set. And I had, even early on, from like having toys like Legos and Lincoln Logs and those types of things, I think encouraged me. And then I had an uncle who gave me a book on car mechanics and how engines work. But I never, I've been asked, like, oh, have you faced challenges in construction as a woman or in engineering, any pushback? And I thought, no one ever told me before that could be a challenge. I never even thought it would be something I would face, and I really didn't feel that I had to face it. It was just, this is the path I was supposed to follow, and I was always encouraged to do it. And it was almost a surprise that there are so few women in engineering.
Yeah, I mean, it's interesting hearing you talk, that you tell a story that very much aligns with where educational theory is, how you want to encourage kids to become learners. It's like giving them a lot of role models, giving them these very positive, fun experiences, helping them understand, yes, this may be challenging, but absolutely you can do it if you put your mind to it and you keep trying at it, and give them that kind of can-do attitude, and get kids involved in the whole process of sort of loving to learn, basically, and then they'll pursue it on their own. So that's just that's a classic. So do you see the lack of women in the engineering fields as being a detriment to the field and a drawback?
Oh, sure.
Okay.
I think bringing more women into the field can do nothing but benefit. It's been well researched that men and women do think differently. Women tend to have a broader perspective, whereas men have tend to be able to focus more, I guess, is a general way of putting it. And I think having a different perspective on anything is always going to improve it and broaden the field, and bringing in new minds and new thought processes. It can do nothing but benefit it.
Well, excellent, and it's wonderful that people like you are here as sort of role models to others, to students who may follow you.
Thank you.
And think more about that kind of consider this as a career or a calling, as it were. This is intriguing to talk about, and I want to move on and talk now maybe a little more in depth about particularly this area of green engineering, so-called green engineering, to really take advantage of minimizing negative environmental impacts, taking advantage of environmental resources and all. Before we do that, we're probably going to have to take a short break, but we will be back. So I'm your host, Ethan Allen, here on Likeable Science. With me today in the studios is Sunny Walsh. We're talking about civil engineering and how civil engineering is making all of our lives here in Hawaii better. We'll be right back.
Aloha, welcome to ThinkTech Hawaii. My name is Josh Green. I'm the host of a program called Healthcare in Hawaii. I'm a physician. I work in the emergency department on the Big Island. I also serve in the state senate, which, please don't hold that against me, doesn't detract from my television program. We speak about all the big healthcare issues in the state. We get together on Tuesdays from 2 o'clock till 3 o'clock in the afternoon, and we try to talk about the most important issues in healthcare. This is a terrific venue for people to learn about healthcare. There are many programs on this station. We broadcast it later, not just on the internet, but also on OC16. Thanks for joining us. Please be informed healthcare consumers.
And you're back on Likeable Science. Me, your host, Ethan Allen, and in the ThinkTech studios with me today is Sunny Walsh, civil engineer, and we are exploring engineering, particularly civil engineering, and talking about how engineering can really work to help us make all of our lives better. And what I want to talk about at this point is this whole idea of sort of green engineering. Maybe you can, again, start us out with the definition, as you did so well in our first segment on civil engineering. So what is, we hear this term sort of green engineering. What does this really mean?
Well, a lot of people think about green engineering. They think about things like solar panels, electric cars, and that's definitely part of it. From a construction point of view and a building point of view, you're looking at things like energy conservation, how you use energy for inside a home, but also when you're creating a building, the impact of the materials in the building, of getting those materials, the impact of the construction, the impact of your site choice, your site location, all of those things, and how everything impacts the environment. The idea is, you want to conserve as much energy as possible, say when you're heating and cooling a home. So, you don't want to waste energy there. And also including in energy is things like water, how you use water, but also how your site uses water. Things like when it rains, you've probably seen things like water catchment bins where you can use the water to water your land, water your plants. But there's also things like not letting your water run out into the street, and you can design your home and your property to help absorb the water and re-infiltrate into the ground, and even your hard surfaces like your driveway. So instead of water running off of it, it can be designed to filtrate through. Okay. So those are all included.
Excellent. And so this clearly is an important aspect particularly in a place like Hawaii, where being small islands, we have limited amounts of resources. Mm-hmm. And we really want to do as much sort of locally as we can, have to import as little as we can. So it seems like this green idea would be particularly important here. Is it being a sort of an up-and-coming consideration now?
Yeah, it's definitely a growing field. It's something when I first started working, it wasn't really discussed that much. I mean, it's definitely there, but it's become much more popular and available, and the public has been much more aware of it now. You mentioned that I was in the BIA. A lot of people may be familiar with the Building Industry Association. They do a lot of the home building shows that you'll see here. And through that, I was involved in a project called the New Hawaiian Home. That incorporated all these aspects of green building in it.
So you said they actually built a sort of a model or a prototype, totally green kind of home.
Exactly.
With sort of all the best of the best kind of features in it?
Yeah. So they built a home, and the BIA is a nonprofit organization, so they essentially auctioned off the home to help pay for some of their costs within the building. And you can, and then if you go to some of the shows, they'll have it, they'll show you, there's a lot of information available on the products that are used in it to help keep the house, to make it green. And it includes things, like I said, like the driveway allows water to infiltrate through, but even things like your countertops. Granite has been such a popular product for a countertop now, but there's things like recycled materials that you can use that are composites of natural and man-made materials, and you can end up with a product that's environmentally more friendly because you're not doing as much damage when you're getting the materials in the first place, and they're actually cleaner to use. When you're cooking on, they tend to keep less bacteria inside the surface, and then you have like more customability in it. You can change the colors. Or there's even countertops that are made out of recycled paper. And then there's other products you can use. Say you're not ready for a brand new home, but you just want to update and make your house greener. Mm-hmm. Instead of, say if you need to insulate your house better, there's exterior coatings you could apply to the outside, like a paint, which has an insulation value, which can help insulate your house more. So if you're air conditioning it, less cold air will seep out through the walls.
Excellent, yeah. So then it really does, again, we see the tie-ins to other the field, for instance, nanotechnology, mm-hmm. where I know they have coatings they can now put on windows that will sense temperature differences and become either transparent or reflective, mm-hmm. depending upon what's needed or desired. And again, I was thinking that paints that essentially allow virtually nothing to stick to them. Again, to keep your cleaning costs ultimately down, your energy use down in that sense. So yeah, fascinating. So in general, does this green engineering though? I mean, it must be sort of trade-offs, cost benefits.
Of course, yeah. So if you look at a lot of products, some of these like this exterior coating, that's going to cost more. But as products are used more and they're developed better, costs do come down in time. And then if you look at long-term costs, like maintenance-wise, if you're keeping your energy costs low, the cost to maintain your home or building, it goes down over time. Or if you're using things like photovoltaic panels, you're taking in energy from the sun, so you have less cost there. So it's more of I guess you have to look at it as a long-term investment and also an investment in the earth and protecting your environment. Right.
So besides this sort of model home, are there other notable examples of sort of green buildings here around Hawaii?
There are some. Okay. I'm trying to think. I know there was a new project. I think there was a new school that's being built out in Kapolei, which is, and I've only seen some drawings for it. I'm not sure if they've broken ground yet, but I know they were talking about, I think the building, part of it was supposed to be below grade to help with cooling costs, and a lot of them, the goal was to have it very green, very energy neutral, using very little energy that it doesn't create on its own from photovoltaic panels, and also I think and all the materials were supposed to be very earth friendly. So that was an interesting project that I saw that was coming up.
And you said in an earlier conversation that we had firms here who will help sort of move in and take apart an old home and then think carefully about how to reuse the materials in the most effective ways in new construction or repairs or renovations.
Right. If you think about a lot of times what you do is if you have an existing house and you just want to start over, the old way was just to come in and essentially bulldoze it down and demolish it, and everything gets hauled away and put in a landfill. If you've ever been into a landfill, it's a little overwhelming and can be quite a surprising experience. So there are companies that will essentially dismantle a building and reutilize as much as possible. And so that gets put either back into your new home or another home. And so it doesn't go into a landfill, and it's much better.
Right. And again, we see the particular relevance of that to an environment like Hawaii, where space is at a premium. Yeah, you don't want to make your landfills any bigger than they need be, and you want to, again, recycle and reuse your materials as much as possible, because it's going to be much cheaper ultimately to do that than to throw them away and bring in new. The transportation costs alone are going to kill you on that. So, yeah, one wonders how this is really playing out. Some of the I live in Waikiki, and we see that they're tearing down some of the somewhat older, early high rises there now, and I now makes me wonder, are they recycling that stuff, or are they really just taking whole old hotel and sort of using it as landfill?
A lot of concrete products are taken in and they're essentially crushed down, and they remove the old rebar, and that does get recycled into fill material or back into new concrete. So a lot of it is reused. As far as a lot of the, well, you're aware of probably when people were into taking copper. So a lot of that stuff is, there is a value to that. So a lot of that is taken out and recycled. A lot of the metal is recycled. I'm sure there's ways to do more, but there's always been some components of all buildings that have been recycled.
Yeah, exactly. So I guess that gets back then to this whole project management piece. If you're doing a project, then you have to look at all and try to balance out all those different aspects, particularly if you're dealing with an existing structure that comes down, and your different options for demolishing or dismantling it, and the recycling costs versus the new material costs, and all this begins to sound amazingly complex in terms of how you figure out how this is all going to have to, what the best solution is, the optimal solution, I guess.
Yeah, well, right now it's, I think I think the public in general is becoming much more educated. So they have a lot more information available on the internet. You can look up things and learn a lot more and educate yourself a lot more. So if you have a project that you want to work on, from a homeowner type perspective, the resources are there. And then you'd have to work, when you work with a contractor, they can educate you too, but I think in general, the public is much more educated and aware of benefits of green engineering and just of what is available to them.
Interesting, because I know in some fields, for instance, the medical field, some doctors think this availability of information is sort of as much a curse as a benefit in a way, because yes, now all the patients come on in convinced they have some new disease.
Self-diagnosed.
Right, yeah, they're all self-diagnosing, usually incorrectly.
Yeah.
But one would hope maybe that's not quite so much the case in a field like this, where basically they are just gaining useful background knowledge and not too much trying to apply it.
I think generally, and that's why you do have to work with a professional to gain knowledge, but I think as long as you're kind of directed in the right course and realize that, I've read it online, so I can build the whole house on my own, or I can build a whole high-rise on my own, or I can run a crane on my own. As long as you understand that. Right.
There probably are sites where they'll tell you can do that.
Yeah. Yeah.
And we just got to hope not too many people go to that.
Yeah.
Well, that's intriguing. And so these other, again, it's amazing to me to think about how then all the fields, these other aspects of engineering can tie in, because this recycling gets you back into sort of chemical engineering, right? How do you grind up and reuse concrete to new concrete? There must be recipes for that, and again, depending on exactly what use it's being put to, you may need to grind it coarser or finer, or mix it with more or less new concrete, and so quite a balance of interesting pros, cons, costs, benefits that you have to play with here.
Concrete in particular is kind of a funny material, because it's been around forever. The Romans used it to build the Colosseum, but now some of the basic recipe is as it was originally made, but then there's also, like you said, there's new chemicals that are added, and you can make it stronger, faster, or pliable and workable longer, and you can make it more colorful and do more things than you ever could before.
Right, even working, I understand, on having concrete that is self-healing, that if it cracks, it will actually, over time, be able to meld itself back together, which is...
I'm sure that is expensive too.
Indeed. Well, this is fascinating stuff to talk about all of the green engineering aspects here. We're going to go to another break here in a moment. You're joining us here on Likeable Science. Sunny Walsh, a civil engineer, is talking with me, your host, Ethan Allen, about civil engineering and how it's working to make all of our lives better here. We will be back shortly to have another piece of this conversation.
Aloha, this is Keli'i Akina. It's my privilege to be the host of Ehana Kako, a weekly program on the ThinkTech Hawaii broadcast network. Ehana Kako, what does that mean? Well, many people have heard of Epule Kako, let's pray together. Ehana Kako means let's work together. Let's work together to build a better economy, government, and society. And every week, Monday, from 2 to 3 o'clock, you will see movers and shakers and other people who are working together to build a better economy, government, and society. Again, I'm Keli'i Akina on the Ehana Kako weekly program on the ThinkTech Hawaii broadcast network. Aloha. See you here Mondays, 2 to 3.
And you're back here on Likeable Science. I'm your host, Ethan Allen. With me today in the ThinkTech studios is Sunny Walsh, a civil engineer. We've been talking about civil engineering and the whole construction business, how projects get managed, how so-called green technologies get incorporated, the whole pros and cons, costs and benefits of recycling materials, and how that's sort of growing business these days. And I want to try to get a little maybe more in depth here about how this plays out here in Hawaii, because it seems to me Hawaii is different than a lot of other areas in various sort of aspects. I mean, one, being a small island, its own resources are much more limited. Everything to bring in stuff is much more expensive. You can't just truck it in from the next state over. You've got to dump it onto a ship and unload it again. And so, but beyond that, Hawaii is a very complex environment. It's got a lot of micro environments where things change very rapidly. It's got beautiful things, wonderful airflow over parts of it, but intensive sunlight. And so, can you tell us a little more on how you try to balance those out, and how do you play off the intense sunlight versus airflow play, you know?
Well, some things you think about, because we do, like you said, we have so many different microclimates. A lot of general house designs are based on kind of broad perspective, and they don't look at specifically where you live. So you really want to design a building for its exact location. I live on the windward side. I don't have air conditioning in my house, and what we do is we keep our windows open. We have our house is set up so the airflow naturally comes in from the windward side, and we put in a whole house fan, which helps draw the outside air in, and it's very comfortable. You know, and so I don't have to live with air conditioning. But in the windward side, especially in Kaneohe, we tend to have more rain in the cloudy days. So things like the photovoltaic panels or solar panels may not be as usable. You can still definitely use it, but on leeward side where you have more sun, you have things like solar panels, and even out in Kapolei we have whole fields of photovoltaic panels that are used to create energy. So you really need to design and build for your specific location to optimize what you're doing, to optimize your home or your building.
Right, because you see some of these buildings are oriented with all the apartments in a high-rise facing directly southwest, and these places just get blasted every afternoon of the year with full intense sunlight for hour after hour after hour, and you know every unit in that side of the building is using air conditioning, and every unit on the other side isn't.
Right. Yeah, and that's definitely one of the, part in the guidelines. When you talk about like the National Association of Home Builders, they talk about for part of green design is just orienting your house differently relative to the sun, and using things like eaves to create more shade in your house rather than having to air condition, or using more energy efficient glass in your windows rather than just turning up the AC, which if you have air conditioning, you know how much it costs.
Right. Again, we try to avoid our AC, and again, you've got whole design features like if you're in apartment buildings with a single stack versus a dual stack, and you get that cross flow of air that's so critical. It'll help, again, dramatically reduce your need for air conditioning.
And here in Hawaii, if it's so beautiful out, why not bring the outdoor air in rather than trying to keep your cold air in? Exactly.
It sort of seems like a no-brainer here in Hawaii, and there are generally 200 plus days a year still trade winds blowing. So you get that kind of airflow going. It seems only sensible, but I guess it is again a set of factors to consider in any building. I know in the high rises, yes, if you put in, for instance, bigger lanais, you can get better shade. But again, then adding the initial cost of the building and probably the sort of complexity of it to put in larger lanais. But then it pays off in the long term in terms of lower energy use.
I think also it's a factor of like understanding fully like what type of energy you're using. There are resources now where you can actually hook up your house and essentially have a measurement and figure out how much you're using at any time. I mean, you could look at your meter, but it's not always easy to figure out how much energy you're using. But there's apps now you can figure out exactly what you're using any time of day. How much is your refrigerator using? How much is your TV or all of having your lights on or leaving on your gaming consoles? Like how much energy all of that uses. And I think having awareness will make an impact, can make an impact on your behavior, and that's part of like educating the public and how that can create change.
Right, and there are groups who will come around and do quite detailed energy audits for you, I gather now, who walk through sort of each room in your house and discuss how and where the energy is being used there, what you can do to minimize the energy use, etc. So that's certainly a huge issue. And then again, these new materials that are constantly coming out, new types of solar cells, getting even away from the silicon-based cells. There's really a push now to move that next generation where it's going to be much cheaper to build the solar cells, basically, and then they'll become much more broadly applicable, even if they're slightly less efficient.
Yes. As materials are explored more and manufactured more, they become cheaper to use. And there's even things like your roof shingles are changing now, so those have an energy rating to help. They have an insulation value to them to keep your house, help keep your attic cooler. Because if you've ever been in your attic in a middle of the day, it is not comfortable.
Indeed. So yeah, in all these different ways, it seems like civil engineering is really critical to looking at issues of energy use, sort of environmental sustainability, can really have a profound effect on the whole state's ability to maintain themselves and to sort of hit achieve our state goals of being more self-sustainable. So that's truly inspiring to think about then how you can do that.
Yeah, we're all aware it's a small state with limited space, and we have to plan in order to make space for everybody, in order for everyone to have everybody's going to need a home to live in, and we have to have schools for all of our kids to go in. We have to have grocery stores for everybody, and that all takes space, and you just have to make it last as long as possible. We have to plan accordingly. Right.
You want all these to be as comfortable environments as possible. I know there's a big brouhaha going down in the schools right now about should they air condition all the schools, and clearly if they were well-designed buildings do not all have to be air conditioned, as you were observing, and obviously in some parts of Hawaii, yes, they inevitably will need air conditioning, but in other parts they probably could incorporate design features and avoid that.
Right.
So, but of course parts of it you're stuck with the buildings that existed, and you live with that. I was thinking when we were just discussing this, the classic stories about when the missionaries first came to Hawaii and set up and built classic New England houses in Hawaii, and then of course found these houses reasonably unlivable because the houses just weren't site-based, as you were pointing out. They were designed and built for one environment and now trying to be applied in another one, and were quite impractical on so many levels. So it's very neat to think about. So how do you see civil engineering sort of evolving as a field now? Where do you think it's going? How is it going to help us?
Well, I think we are going to continue on this path of green design, green building, green engineering. That's definitely a part of what's happening now, and I only see that increasing and improving and being a bigger component of what we're doing. We're all so aware of our limited resources in many different ways, which from energy usage to just the accessing the materials, and then even land use. I think that's going to continue to grow. And then also when we look at design, when we're designing neighborhoods and city planning, we're looking at the trend is moving towards more compact building and more vertical building, where you're going to have smaller living spaces and more vertical living spaces, but then green space for common areas, and that's how you increase density in an area and a living space. But you still have a community, and you can still have outdoor living space for people, and that's definitely going to be a continuing trend. And fewer neighborhoods where you have large lots for single-family homes. That is going to be, we're going to be moving away from that. There's really no choice. Right, and again, it will help on so many levels. That kind of design will help reduce the need for cars. Not everyone's going to need their own car in that kind of neighborhood. You'll be able to walk to to all the places you may need to go, or so infrequently need a car that you can do more car share services or whatever. So that, and again, that's going to cut down on the need for fuel for Hawaii, and we are seeing that our condo building where I live just recently has set in a car share service now, so that some of the residents who don't have cars, and there will be less need for you to have, or maybe only need one car instead of two, depending upon what your needs are. So all this is these are very positive trends then. Yeah. So given that
you're such an advocate of engineering, so enthused about it. What would you say to younger students who are going into engineering or maybe considering careers in engineering? What advice would you have for them?
My first instinct is to say, just do it. Obviously, I have a passion for it. I love what I do. I love what I've done over the years. I think it's a great field to go into. I do think we need more people to be interested in science and engineering and to go into it, and especially women. I think I'm a big supporter of higher education. Go and get your college degree, but in the science fields and engineering fields. I think also you should explore it. Explore, what are your interests? We talked about before, when you're a kid, especially, you don't know all of the careers that are out there. You have no idea. I know how many people now are in a career that when they thought of, like as a kid, I'm like, oh, that's what I want to do. Because you're only aware of so much, but as you become more aware of what's available, it's definitely worth trying. And as if you think you may want to do something, try an internship program. Just explore it, and don't think you can't do it. Just look for people that are in the field and talk to them, and you can do it. There's nothing that can hold you back as long as you're interested and you're focused and determined. Excellent sound advice. And at sort of a practical level, I assume you'd urge them to prepare themselves early and well in terms of science background, math background. Oh yeah, and I've told you before, I've always had an interest in math and science from a young age, and you definitely, in all through school, it was a very important part of my background. And in college, it was essentially all of my background. So I'm a big supporter of education, encouraging your kids to go to school and being active in kids in your children's education from a young age. Talk about it and talk about what their interests are, and share in their interests, and try and encourage them to explore whatever your kids may be interested in. But if they're interested in engineering, really encourage that. Yeah, again, you hit on a very interesting point here, the whole affective component of education, getting people emotionally engaged, where they find something appealing, that they want to learn more about this, and they'll go off on their own as a child and start reading more materials, looking at things, nowadays surfing the internet to find more and more information. Where can they learn more about whatever it is, whether it's rocks or rocket ships or whatever. So certainly that's a critical part, is to instill that love in an early stage. Well, this has been most fascinating, Sunny. I thank you so much for being here with me today. We've been exploring the ideas of civil engineering and how civil engineering, green engineering can help all of us, men, women alike, make our lives better here, particularly in Hawaii, and how people come into the field and ways they can contribute to everyone else's lives and make the world a better place. So this has been wonderful. I thank you so much, and wish you the best. Thank you, and you're welcome. Ethan Allen signing off.